Hello everyone. This video will be part 1 of 3 on the subject of file I/O, simply because covering all the information together would make this video a little too long and I'd like to try to avoid that. Throughout all 3 parts, I will be covering the 2 modules used for handling file paths and the actual I/O operations for files. In this video, I will be talking about the first module used for working with paths, the OS module. The OS module is the more commonly used one because it has existed for a long time and is more well known. However, nowadays, it is highly recommended to use the other module, pathlib, which will be covered in the next video. Still, it's good to know how to work with paths using the OS module as well. So to make this easier and more organized to demonstrate all the stuff with OS module, I'm going back to using a Jupyter notebook file, but everything I demonstrate can easily be carried over to just a regular Python coding file. So it's not going to be anything significantly different just because I'm using it in a Jupyter notebook file. In order to use the OS module, we have to import it, and we do this by simply typing import OS, as you see here. I'm going to go ahead and run this so that OS will be imported for this entire Jupyter notebook file. Now, a lot of functions we'll be using are technically in the submodule path. However, there are some functions in the main OS module that you may occasionally need as well, so it's recommended to simply import it like this. When we utilize functions and various libraries to open files for reading and writing, they usually expect, at the minimum, a string. Nothing special. Because of this, the OS module does not provide any sort of class for paths. It simply provides various functions to help generate and modify paths and returns all paths as strings. Now, I'm not going to go over all the functions in the OS module for file handling and stuff, but I am going to go over a great deal of the functions that you would more than likely use if you were to use the OS module for all your file stuff. Starting with the join function. So the join function allows us to take individual strings and combine them together to create a full file path. So in this example, I have a variable fname. It stores the path home/crozo. And then we use the os.path.join function to join other words to that path to create an even bigger path. And we could actually keep adding more names to this. There's no limit to how many comma separated words we can put into this function. So we could just have 2, or we could have like 10 and so on. So it will combine them all together. So if I run this, /home/crozo/codebase Python tutorials, another directory. That doesn't exist, of course, but this isn't checking to see if it exists. It's just assembling a path that we asked it to. The os.path module also provides functions that can help us extract information from a path. In this case, basename will extract the file name from the path given. So when we run this on the path right here, it'll extract test.txt from the given path and leave everything else out. So if I run this, test.txt. Wow, really? It's a wonderful time for that to pop up. We can also extract the directory information from a path using the function dirname. So when we pass this path into dirname, it's going to give us /home/crozo and leave out the test.txt part. See? This is particularly useful if you want to remove the file name so that you can use the directory to maybe append a different file name to it and open an existing file, or maybe even create a new file within that same directory. And the useful thing about dirname is that we can stack the function calls in order to get something deeper down. So maybe say we don't want /home/crozo, we just want /home. So we can stack these two function names together to return just /home. I put them in separately so it's easier to read and understand the example, but in some cases, a lot of people might put the second function call here inside of the first function call, so it gets all calculated in one line. And so when I run that, we just get /home. And finally, we can extract the extension from a given path. So what this function split extension will do is take the file path and split it between the extension and the rest of the path, and it will store the results into a tuple with 2 elements inside of it. The first element will of course be the first part of the entire path, and then the second element in the tuple will just be the .text part. See? There are also functions that help us test given paths. In this case, we're simply checking to see if the path exists. Whether it's a file or directory or something else, this function will be able to return true or false on whether or not the path exists. So in this example, I just fed in a relative path, crozo/test.txt. Now, the way Python handles relative paths is it looks for the path relative to the point of the program's execution. In this case, it's going to be the directory in which this Jupyter notebook file is stored. And if we look here real quick, as you can see, I have nothing in here. So this will return false. So if I run this, it says false. The file does not exist. However, if I were to modify this and say, specify a full path, home/crozo/test.txt, and then run it again, that will return true because I do in fact have a test.txt file in my home directory. This function here will help us test to see if the given path is a file. So even though it's called test.txt, I could easily have a directory called test.txt. So this is going to test to make sure it's an actual file, which it is in fact a file. And if I were to modify this to just point at my home directory and run it again, it's going to print nothing because it's not a file. And then of course there is a function to help us test to see if a path is a directory. So in here, if I run this, home/crozo is a directory. And of course, if I'm to specify the test.txt file, it prints nothing because the test.txt file is a file and not a directory. It's important to note that if we were to use is directory or is file on a path to something that doesn't exist, it's still going to return false. It's not going to return an error saying, oh, this doesn't exist, so we can't really test that. It's just going to return false. So it's always important to check to make sure the path exists first before checking to see if it's a file or a directory. Now for all these examples, I've used fully typed out paths. I didn't use the tilde key for any of them. For those of you who don't know what the tilde key is, it's basically a shortcut to saying the home user directory, the current home user directory. It's primarily used by Linux and I believe Mac OS as well. Windows does use it if you're using it in the PowerShell. The command line does not recognize the tilde key. Python does not automatically recognize the tilde key and expand it. So if you try to use the tilde key in a string inside the program and you try to access a file or directory with it, Python's going to say it doesn't exist or that it can't find it because it doesn't know to automatically expand the tilde key. Fortunately, os.path provides us with a function to expand the tilde key, which I have right here. So in this example, I'm going to print out home before I expand it, and then we're going to print out home after I expand it. See? So the function will expand it to /home/crozo. And it doesn't have to be the tilde key by itself. You can have a full path going on here. And then run it again, and it will still be able to expand the tilde key. And I have an example right here if we were to try to use the tilde key in a path that's coded into the program. So if I run this, we will get this message here saying it's not a directory. It absolutely is a directory to us because we know that tilde key should expand to the home user, but Python doesn't do that. So it says it's not a directory. However, if I do that and then run it again, it now recognizes it because it fixed the tilde key before checking to see if it's a directory. And finally, we have is absolute. This is to check to see if a file path given is an absolute file path and not a relative file path. So I've mentioned relative and full file path and quite a bit throughout this video. Absolute file path basically just means that it starts from the very beginning of the file system. So in Windows, it would start at C:/ whatever to whatever target you're going for. So for Linux, this would be considered a full file path, and this would be considered a relative file path because we're not starting from the beginning of a directory, we're just specifying the name of the file. In this example, this for loop will loop through this and it will say that this is an absolute path and that this is not an absolute path. And there's only a function to check to see if it's an absolute path. There is no function to check if it's a relative path in the OS module. So if I run this, so it says the first one is in fact an absolute path and that the second one is not an absolute path. And that's about it when it comes to path handling using the OS module in Python. One of the benefits of this module is that all the file paths that are returned as strings, which makes it compatible with every module out there that utilizes file IO. Whether it's a Python plugin or a third-party plugin, at its core, file IO just needs a string representation of the file path to open the file. But at the same time, however, it's sort of a con because you just have this string that you're constantly passing into functions to manipulate to get the path you need. And while we have plenty of functions that can do a lot of the stuff for us, not to mention in an OS compatible way, there might sometimes be times where you have to do something a little more complex that might even require a bit of manual string manipulation on your end as well. How complex the manipulation needs to be, whether you need actual manual string manipulation or you're just calling a bunch of these functions over and over again, sometimes stacking them inside of each other just to get the path you want, it really depends on what you're trying to do. But it can be very problematic and messy at the same time. Another issue with the OS module is that the OS module is not just used for path stuff, it has other things as well. Process management, system information, some other stuff. So when you import the OS module, you're loading all of that into memory when you run your program. It's not a significant amount, but if it's something that would bother you, then it's important to know. So even though OS module is pretty useful, it does have its cons as well. So that's it for part 1 of file IO in Python, where we went over the OS module. And in part 2, we'll be going over the pathlib module, which is a more recommended modern way of handling paths in Python. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.